I made a claim last class, that if you can get 7% return, if you can get 10% return on your money will double every what? 7 years. Remember that claim I made? And I said the bank uses that equation. The amount of money you will have is the initial amount, e to the power of r times t. And my claim was at 10% interest rate, your money will double every 7 years. That's the rule of thumb. You're going to find out shortly it's less than 7, 6.93. So let's go through the math and see how we're going to solve that. So let's say I go to Bank of America and I open an account with them, and I said, I'd like to deposit $1. I can use any amount, by the way. When there's $100, I'd like to open an account. There's $100, and because that's a large deposit, they're going to give me 10% interest rate on my money. Huge deposit. It's not a small amount there. And my question is, how long is going to take for that money to double? To double is going to be what? How much I'm going to have? 200. This is where the log comes in handy. How do you solve an exponential equation like this? How do we solve it? Well, the first step I'm going to do here, mathematically, the smart step, is divide both sides by 100 to get rid of that 100. So if I do that, I'll have what? 2 equals e to the power 0.10t. And again, take a look at your calculator. What's above the sign? The inverse sign. See, it's sine to the minus 1. What's above the cosine? The inverse cosine. What's above the tangent? The inverse. What's above the natural log? That's the inverse. Well, if you remember something about the inverse says if you take the inverse of a function, what's the answer to that? Or the function of the inverse. What do you think the answer to that is?
1 over f of x.
Just x. The function of the inverse, they cancel each other out, is going to be x. Watch this. If I take the log, common log, of 10 to the power of 4. Go ahead, do the math. I know what the answer is. It's going to be 4. These two are the inverse of each other. They will cancel each other out. But take your calculator to test it. Let's go. Let's see. What is 10 to the 4? Actually, I'll use this one because I can write the whole thing. What is the log? Where'd you go? Where is the log? I lost it right here. What's the log of 10 to the power of 4? I'm claiming the answer should be 4. What do you think? Did we get the 4? Let's hit enter. What's the log of 10 to the power of negative 2? What do you think the answer is? Try it. What is the log of 10 to the power of negative 2? Could it be negative 2? Because 10 to the power and the log are the inverse of each other. They will cancel each other out, and you end up with the power. So as a rule, if you want it, the log of 10 to any power, it's always going to be the power. Always. And the same rule, we can test it with the natural log. You will find that the natural log of e to any power is just the power. Because e and the natural log are the inverse of each other. They will cancel each other out. So if I write the natural log of e to the third, the calculator should give me a 3 if I do it. Let's try it. The natural log of e to the third should be what? 3? Yep, right there. So here's my equation. If I want to solve for t, I need to get rid of the e. And what's the best way to get rid of the e? You take the natural log of both sides. So the natural log of 2 equals the natural log of e to the 0.10t. I just finished saying the natural log of e to any power is what? The power. So what's my power here? 0.10t. These two will cancel each other out right here. Equals the natural log of 2. How would I solve that for t? What do we do to solve for t? Divide by 0.10. So let's go to your calculator. Take 2, the natural log of that. Now divide it by 0.10 equals. And what's the answer? 6.931 years. Your money will double every 6.93 years. So to make our life, we're trying to estimate how much money you're going to have. We go every 7 years, your money will double at 10%. Every 7 years. So we're going to try to solve a problem like this, exponential equation. That's our goal. And again, if I have 10 to the power, I will use what? The log, because the log and 10, they cancel. If I have e to the power, I will use what? The natural log. If it's not 10 or e, we'll show you that after. So let me take another example. I'll just go to the back of the book, pick some problems, and go through them. Okay. 10 to the power of x minus 5 equals 7. Solve for x. I made that up. It's not in the book. I couldn't find anything in the book yet. So what can I do? Yep, the log of both sides. And the log of 10 to any power, we said you can end up with what? Just the power. So these two will cancel each other out. And you end up with x minus 5 equals what? The log of 7. Can we solve for x? You add 5 to both sides. X equals what? 5 plus log of 7. If they ask you for an exact answer, leave it like this. Don't touch it. So if they ask you for exact, leave it like this. If they ask you to approximate, then go ahead and use the calculator. You go, what's the log of 7? Add 5 to it. .845. If I have e to the power of 0.2x plus 8 equals 3. Solve for x. What do we do here? Natural log. When you have e to the power, use the natural log. And I said the natural log and e, they will cancel each other out. So what do you have left? 0.2x plus 8 equals the natural log of 3. To solve that, what are we going to do? Subtract 7 from both sides, right? So 0.2x equals what? Negative 7 plus the natural log of 3. I'm subtracting 7 from both sides. I don't like to put the negative 7 or 8. I don't know. Good, I'm glad you're paying attention. I don't like to put the negative 8 at the end of that because I don't want people to think 3 minus 8 and subtract the two numbers. So I put that in the front. I forgot, I should have his email. He told me he has to leave at 7. He has another 2 more classes to leave at 7. So to solve for x, what do I do now? Divide by 0.2. Well, dividing by 0.2 is the same as multiplying by what? What's 1 over 0.2? Isn't that a 5? So when you divide by 0.2, it's really the same as multiplying by 5. So that's 5 times negative 8 plus the natural log of 3. They might say this, fine, leave the answer like this. But if you want to get carried away with it, that's negative 40 plus what? 5, the natural log of 3. And if you don't like the 5 here, what do you do with it? Make it a power. So that becomes what? Negative 40 plus the ln of 3 to the power of 5. What is 3 to the power of 5? I don't even know where the power on this. Is it 243? Yep. So it's negative 40 plus the natural log of 243. Again, the 5, just take 1 over 0.2. That's what a 5 is. Now the question is, okay, what about if it's not 10 or e? Now you got 6, you got a 5. Then we're in trouble. Not really. So what do I do now if it's 6 to a power, 5 to a power? Here we go. Let's make one. 5 to the power of 2x plus 1 equals 25. I tricked you here. For this, I don't need a calculator. I don't need to use any of the log even. Why? What's 25? Isn't that 5 squared? Yeah. So if I rewrite this, if this side is equal to this side, the base is the same, that means what? The exponent have to be the same. No calculator is needed here. Subtract 1 from both sides. 2x equals what? 1. X equals what?
0.5.
Yep, a half, 0.5. You go, well, you made it nice. I said, yeah, I did actually. You try this one now, using that method, you're out of luck. There's no way I can take the 13 and write that as 5 to a power. At least me. I have no idea 5 to what power is 13. I know 5 to the 1 is 5, so it's more than 1. 5 squared is 25, so it's between 1 and 2. I can start guessing. I go, well, let's try 5 to the power of 1.5. Oh, close. How about 5 to the power of 1.6? Oh, went too far. 5 to the power of 1.58. Oh, 5 to the power of 1.58. Oh, 12.7, more than 5. I forgot. I used what, 1.58? How about 5 to the power of 1.59? Getting close. I can guess, keep guessing until I get that, but I don't want to guess on it. So what do I do then? Since this number is not 10, I'm not going to use the log. Since this number is not e, I don't have to use the natural log. So now it becomes preference. Which one do you like? It really doesn't make a difference what I use, the log or the natural log. So if I take the log or the natural log, I will choose the natural log for one simple reason. When you write that 2-letter versus 3, the log is always log, the natural log is only 2. So less writing. That's the only reason. But I don't have any other reason to give you. Can I take rule number 6? It says move the power to the front. Times the natural log of 5 equals the natural log of what? 13. I don't want to distribute that, so maybe I should divide both sides by what to get rid of the natural log of 5? Two x plus 1 equal what? The natural log of 13 over the natural log of 5. How do you solve it for x now? What do we do? Do we subtract 1 from both sides? And to solve for x, what's my final step? Divide the whole thing by 2. If this is exact answer, that's what your exact answer is. If this is go ahead and use your calculator, then you can. You go, let me find the 13, the natural log of it. Divided by 5, the natural log of that, get the answer. Subtract 1 from it. So the top is actually 0.594 divided by 2, 0.297. So if they ask for exact answer, that's your exact answer. That's your approximation. I'll try another one in case that's still not Sinking in. 3 times 14 to the x equals 400. Now, you never want to have 3 times that. Because if you take the log of this side, what are you going to have? That's a multiplication. The log of 3 plus. So it's easier if you just divide both sides by 3 first. It's always easier that way. (14 to the power of x equals what? 400 over 3. And leave it the way it is. Again, that number is not a 10 to the power, is not e to the power. So you get to choose. Last time we did what? The natural log? Maybe this time we should use what? The common log? Just to practice. Rule 6 says you can do what with it? Move x to the front. I think rule number 4, is it 4 or 5 when you have division? 5. It says you can break it down to what? Log the 400 minus what? Log 3. You want to solve for x? What do? Divide by the log of 14. So that's what your answer is. The exact answer is log of 400 minus the log of 3 over the log of 14. And again, if you have a calculator, if they said exact, that's your exact answer. If they said simplify that, let's go to the calculator here. Log of 400. Make sure you close the parentheses for each one. Minus the log of 3, if your calculator gives you parentheses. Take that answer divided by the log of 14. X equals what? 1.854. Everyone get that? If you decide to write this all in one shot, make sure that you put parentheses around this to tell the calculator do all the subtractions first, then divide the result by that, if you decide to type it in one shot. Otherwise, the order of operation will kick in, and it will be the wrong answer. This is how we solve exponential equations. If you look at the topic of our lecture today, this lecture was solving exponential and logarithmic equations. We did some of these. We'll go back and revisit them. So we know how to solve exponential equations now. Let's look at logarithmic equations. We're still in the same section. And you've done the homework on that when you were combining, playing with the rules last class. Let's say you have this problem. 5 log, I don't know, pick a number for the base. Can't be negative, can't be 0. 1. What number? 3? Okay. Of x equals what? Negative 3. That's a logarithmic equation. How do you solve that one? We have to apply the rules that we learned. The rules are what? If you have a number in the front, rule 6 says that number used to be what? R6. That number used to be the exponent. So the question we solve for x. So that used to be log base 3x to the fifth equals negative 3. Notice the log is only on one side. Remember what I said when the log only on one side, what the rule is? Which one?
3.
Very good, rule 3. I should be able to change this from this to exponential function. X to the fifth equals the base. What's the base? 3 to the power of what? Negative 3. What's 3 to the minus 3? Yep, it's 1 over 3 to the third. And you are right, it's 1 over 27. How do you solve for x?
Square root.
Not square. Fifth root.
Fifth root.
Yep. The fifth root. So x equals the fifth root of 1 over 27. That's your exact answer. You might want to simplify it because the fifth root of 1 is 1 always, right? So you can write that the fifth root of 1, the fifth root of 1 is still 1. So you can break it down to 1 over the fifth root of 27. But if you want to use your calculator, how do you find the answer to this on your calculator? That's 1 over 27 to what power? When it's fifth root. The power of 1 over 5. Make sure you put the power in parentheses when you type it. So here's my calculator. Watch what I'm going to do. Clear. Can you see it on the screen? Yep. Parentheses. 1 divided by 27 to the power. Where's the power key? And what I said the power is what? 1/5, right? Make sure in parentheses. 1 divided by 5. The 1 over 5 better be in parentheses. Because if it's not, it's going to raise this to the power of 1, which doesn't change it. Then take the answer and divide it by 5. And the answer 0.5173. .5173. Let's try another one. Log base 7x plus log base 7 of 9 equals log base 7 of 54. Solve for x. Every problem is different, I'm giving you. No energy tonight. Come on, guys. The candy's supposed to get you going. What can we do? What rule?
power? Or
Isn't it 4?
Yes. When you have addition, it used to be multiplication. I know what you meant, 9x. So you can write this 9 times x. Now here you got the log on both sides, the same base. Thank goodness. If this side is equal to that side, you have the log on both sides, the same base on both sides.
that's the basis. We can divide by logs.
Can't divide by log 7. Log 7 by itself means nothing. But you can drop them out. That's what we're trying to think. Drop them. Because that's this, for this side to equal to that, the only way, if the 9x equals 54, that's the only way they'll equal to each other. But you can't divide by log 7 by itself. Log base 7 by itself means nothing.
Okay,
So you can say 9x equals 54. Can you solve for x? You divide by 9. Is it 6?
What if they're different bases?
Oh, that's a more challenging one.
Can you want to know?
Maybe. Let's see. I got one in mind for now. I don't like to dodge any question. So let me think about that. Try that. I'll give you a quick one after this. Maybe I'll go back to this. I'll use the same one. Since you asked that question, you probably won't see them in this book at all, but since the question came up, I can't dodge it. It will bug the hell out of me if I don't answer it. Again, remember what I said, when you have a number, you always want to isolate the log. So you got to divide by what? Let's divide both sides by 9. So you have log, this is not a good one. The log only on one side. What do we do now? There's a rule that you're going to use anytime the log on one side. Rule 3, very good. Change it to exponential. It says 2x minus 1 has to equal the base. What's my base? It's not written here. 10 to the power of what? 3 nines, or 1/3 if you simplify it. So 2x minus 1 equals 10 to the 1/3. What's 10 to the 1/3? Isn't that the cube root? That's the cube root of 10. And now if you want to solve it for x, don't we add 1 to both sides? 1 plus the cube root of 10. because you got to add 1 to both sides. And to solve for x, what do? Divide by 2. I'm giving you exact answer because I know the software 9 out of 10 times they want the exact answer. They don't want approximation. So that's why I'm leaving like the cube root of 10, the 1, the 2. Question came up. Now, I wasn't planning on doing it. I don't think you're going to see it, but I hate dodging anything, so I'll do it. It takes me 2 minutes. What will happen if these bases are not the same? The question was, okay, what do? So since I get bored with one question once, I'll make one similar to this. So let me make a different one, just similar to this, and I'll give you different bases. And maybe I'll put a twist in it even to make it more fun. Log base 5 of x minus 2 log 4 base 3 equals log log 2 base 3. Log 3 base 3 is 1. So it'll be silly. Oh, I said it'll be silly. I wrote it again. Log 2 base 3. Notice the bases are different here. So the first step in a case like this, you want to make sure log base 5 on one side, log base 3 on the other side. This will be log base 3 of 2 plus, when I take this to the side, that becomes a plus, right? And I can rewrite that as what? Log base 3 of what? 4 to what power? I'll put the 2 here, since you were slow on it, so I'll do one extra step. So that becomes 4 squared. And what's 4 squared? Now the right side, can I simplify that? Yes. 2 times 16, which is what? 32. And here's the problem. Now the bases are different, so x cannot be 32. Can't be. That's the question. What would you do if these bases were different? So I just want to make a different, nicer problem. So, which is how? Can't do LCD. It's not like normal math. Can't change the number to 15 to both them.
Can you divide them?
But the different bases. How about if I use the change of base? Remember the change of base? I can write this either log x over log 5 or natural log of x over natural log of 5. It doesn't matter. So I can make this log x over log 5 equals, I can write that what? Log 32 over what? Log 3. If I'm lucky, this is solve for x, because I can go log x equals what? I can multiply both sides by log 5 to cancel that log 5. So let me go to my calculator and multiply that out. What's log of 5 times? Do the whole thing in one shot. Log of 5 times the log of 32 close every parenthesis, divided by the log of 3. 2.205. Anyone got that number? On the right side. I still didn't solve for x, but now it looks much better. How do you solve it for x? Rule what? Rule 3. We only have the log on one side, I mean. X equals what? 10 to the power of 2.205. $160.32. I like that question. I just made it up. I don't think you'll see anything with different bases here in this chapter, in this book at least. That doesn't mean down the road if you decide to go upper level math class you won't see that, but that's really one way to do it. Change of base will help you, and you can solve for log of x. Now if they said, I really don't want you to approximate that, I want the exact answer, to cancel the log of x, you go 10 to the power. So x becomes 10 to the power of this whole thing. And that will look ugly. You know. Let me try another one. Maybe I'll do ln here. We did a lot of log, but no ln. 3 ln of 2 plus ln of x minus 1 equals ln of 24. When you see the problem has log on both sides or ln on both sides, just say thank you to them, because they just made the problem much easier. First thing I see, there's a number in the front. The number is what? 3. That number used to be, yep, that's rule 6. That used to be the natural log of 2 to the third plus the natural log of x minus 1 and what is 2 to the third? 8. Now you have addition. Addition is what? Multiplication. That's rule 4. Thank you. That's the natural log of 8 times x minus 1. Since the natural log on both sides is the same log, we cancel them out. So you end up with what? Eight times x minus 1 equals 24. To solve it, what do we do?
Divide by 8.
Divide both sides by 8. Make life easy, yep. X minus 1 equals, what's 24 by 8? 3. Add 1 to both sides, x equals 4. That's why when you have the natural log on both sides, yeah, that's not bad. When it's not like, oh, you mean person. One more. Anyone still writing? A lot of caffeine in me today, so just let me know. Caffeine and candy. I love those problems. I don't know how many of you enjoy them, but me, like, oh, this is so much fun. It's like Halloween candy. I notice there's no bases there. That means what?
10.
10, very good, common log. So I see addition there. I know there was a rule, I think R4. That used to be what? Multiplication, right? That's what it used to be. Can we FOIL that one while we at it? What's 2x times x? 2x squared plus 8x minus 1x plus what? 7x minus the 4. The last thing. The right side doesn't have a log, the left side has a log, so that's rule number 3, right? It says 2x squared plus 7x minus the 4 equals what? The base, what's my base? 10 to the 1, which is 10. Now that's a quadratic equation. Move everything to one side. And we can try factor that maybe, and if not, use the quadratic formula. Sometimes I should like pick a problem from the book, so this way I know it's going to work. Can we factor that? You can? I don't see it. I don't think we can factor it. So the quadratic formula minus b plus or minus divided by the 2a, right?
Yep.
So it's minus 7 plus or minus the square root 49 minus 4 times 2 times a negative 14, all divided by what? 2 times 2. Minus 7 plus or minus 49, this becomes a plus 8 times 14. 8 times 14, 112. Divided by 4, plus the 49, 161. So what's the square root of 161? $12.7 roughly. So we have two solutions. One of them is negative 7 plus 12.7 over 4. And the other one is negative 7 minus 12.7 over 4. So one of them is 1.42. And the other one is what? Negative 7 minus 12.7 and divided by 4. Negative what? 4.93. Keep your eyes open on this problem. You cannot use the negative 4.93. Can't use it. Why? You'll have a negative number here. Can you take the log of a negative number? No. Same thing right here. That'll be a negative number. You can't take the log of a negative number. What about the 1.4? That's okay. That's okay. I'm okay.
Where did you get 14 from?
14. Where's the 14?
Where you see R3 and then there's the first equation.
I'll bring the 10 to this side.
Oh.
Right? That becomes a negative 10. Negative 10 minus 4. Negative 14. Do you see it?
Mm-hmm.
Yep. Hope I didn't make a mistake. Otherwise, like, oh, be on the video. So these are the type of equations. That's really why we've been studying the log to solve exponential equation. That's the bottom line. These, we've done some of these, but the key ones, when you have exponential equation, you're looking for the exponents. The only way to do them is through the log. And if you see 10 to a power, you take the common log. If you see e to the power, you take the natural log. If neither, it's not 10 or e, then you can use either one. Just more work. But it doesn't matter which one you use.